Let's do this. All right, find the term independent of x in this expansion. All right, there's a formula for the way to expand it for each individual case. We're not going to do each individual case. We're just going to focus on one concept, which is essentially this formula. N choose k. A, so that's your first term, to the n minus k. B to the power of k. That is essentially any particular term in this expansion. Does that make sense? So if you think of your perfect squares, how many terms do you have in your perfect square expansion? You have 3 terms. So this formula gives you each term, if you want to say that. So the first term, the second term, the third term. Slowly, right? But we're focusing on this particular question. All right. So in this question, what does n equal to? 9. Choose k. That's the term we want to find. A. What does a equal to? 3x to the power of 9 minus k. I've got a lot of people asking me lately, now that they're doing this and they're starting to understand this, they're asking me, Sam, does it make a difference which one's A and B? Good point. No, it doesn't. So you could have made A this one if you wanted to, and B this one. So in other words, you could have made this k and this n minus k. It doesn't matter. The math is meant to add up. Why doesn't it matter? Pascal's triangle is symmetric. So it actually does not matter. So you pick, as long as you know it's n minus k and then k. Back to it. 3x and then negative, I'll do it slowly because it might have been a while. So let's do it like that. Negative 1 over 2x squared to the power of k. I'm going to run out of room. So I'm going to just bring this to another page. Now, the logic is we want to group our what together? And yeah, x's. We want to group our x's together and our constants together. So we don't want to have it looking the way it looks right now. So next line. This doesn't change. 3. I don't want it attached to the x. So I said numbers by themselves, x's by themselves. So it's got to be like this. 3 to the power of 9 minus k, and then x to the power of 9 minus k. Now, how do I make this by itself? Let's think about, let's see if you guys agree with me. Negative a half to the power of k. There you go. I just took out my constant. And then x should have been x to the power of negative 2 to the k. Agree? It's good. Now I've separated them, but I only wanted x's together and my constants together. So now we're going to put it all together. So it's going to look like this. 9ck, 3 to the 9 minus k, negative half to the k. So I just grouped all the constants together. And then x to the power of, what do we do when we multiply x's that are the same? We add the indices. So that should be 9 minus k plus negative 2k. Right there, negative 2k. Are we happy with that? We're almost there. Next line. I mean, I wouldn't waste another line rewriting everything just to, you guys should know me by now, to just write negative 3k. I would never do that, ever. So I hope you would never do that if you had written everything the way I've written it. You would just say, I'm looking for the independent term, which means you're looking for x to the power of 0. Right? If you were looking for x squared, your math is exactly the same. You just make the power of x there equal to 2. X cubed, you make it equal to 3, whatever. But the math should all be the same, exactly the same. All right. Independent, I'll just write that, independent. We're making 9 minus 3k equal to 0. What does k equal to? K equals to 3. Now that you know k equals to 3, you're obviously going to sub it in. So the answer I'm looking for is 9c3, 3 to the power of 6, negative half to the power of 3. You don't need to sub it into the x because it's already going to be independent of that. And then that's it. What's the answer? And 1 mark for use of the binomial, 1 mark for the k, 1 mark for correct term. I think we already know that. It is, if you write it as a decimal, negative 65450. Negative 6555450.
Can you just leave it as that?
Can you leave it as that? Honestly, yes. Yeah, 100%. That's it. All good? Andy, you feel like you can memorize that, eventually execute it? Yep, sounds good.